Hello everyone, I am pleased to have everyone in today's tutorial and even having new ones amongst us. You all are most welcome. Today's teaching is very common, especially on the internet. If you go through the YouTube or the VidMate, you will find an exact type of today's tutorial. So that means it is very versatile. But sadly, as versatile as it is hardly explained. You see, most tutors or content creators will just simply tell you the little basic that they want you to know. They will tell you where to place your wires or how the batteries should be connected. I'm saying this because I have been a victim of it, seriously. So it is literally not just knowing the common knowledge of the tutorial, but rather being able to ask series of questions on how calculations are done by our regular computers. Albert Einstein wasn't just named a genius because, he discovered relativity, but he was actually a genius because of curiosity. Curiosity really announced him because he asked questions on how things worked around him. He didn't just, assume that, okay, this is this. If you type in 2 plus 2 and then the computer gave you a result which is 4, the question is, how is this calculation actually done by a machine that don't even understand our human language, only ones and zeros? Logic gates. They are electronic components that are embedded inside the computer processor. They perform these arithmetic calculations and also logical operations. Just like your food microwave, when you open the door with the handle, a light turns on, but when you close the door, the light turns off. And even sometimes the light turns on while our food is being processed inside the microwave oven. Now ask this question: what is actually responsible for the turning on and turning off of the light? It's still logic gates. Our tutorial today is just very easy to comprehend because it is versatile. It's just that there are some key details and terms that need to be explained for you to understand and for you to be able to build other circuits. Now I have a story for you. One time during my high school days, my teacher, he was given an explanation on logic gates, and then I love being abstract a lot. I really don't like going with what everybody is doing. I love my own things quite different. Okay, back to the story. So I curiously asked him, what is the evolution of the logic gate? Where were they gotten from? Were they actually gotten from the grounds like our minerals? I was quite young then, so I can actually ask some funny questions. And so the whole class laughed at me, and then my teacher said that is a question for another day. But I didn't give up there. I pondered on my books, to find the answer. Then I didn't have a phone to check the internet. So I started the research, and I understood that since the era of transistors in computers, there have been an evolution whereby transistors are being put together to create ICs, that's the integrated circuits, like the logic gates. That means that the foundation of logic gates and most IC is based on transistors. Now, these transistors are either connected in series connection or in parallel connection, but we won't really dive into that. There are 3 major logic gates, which include the OR gates, the AND gates, and the NOT gates. But we will be operating with the AND gates with serial number 7408. And now, let us watch the video. Okay, to start up my project, I have already inserted my AND gate inside of my breadboard. Every IC today, you go to the electronics store and you get some IC components. Now, these IC components have series of numbers and characters that are printed on them, including the AND logic gates, which we'll be using today. These digits, they help to identify the specific functionality of each gate, making it very easy to design and build digital circuits. In other words, the performance of every IC differ in regards to their serial numbers. So if I should get an AND gate 7408, the way it will perform will be different from the way an OR gate will perform based on the serial number. The 7408 is the actual serial number for the AND gate. So if you go to an electronic store to buy an IC, you don't just ask them for an IC. You need to be able to provide the serial number, because it's with that serial number they'll be able to know what you actually want to buy from them. Another term that I will be explaining is the VCC and the ground connections. The VCC refers to voltage at the collector, or you can say voltage at the circuit. This is a positive voltage supply that powers up the circuit, while the ground represents the negative voltage. It is the reference point for the circuit voltage. Just let it stick that the VCC stands for 1, which is positive, while the ground stands as 0, which is negative. But they are both very, very vital components. Let's proceed. So what next I will be doing is to connect my 9-volt battery to the breadboard. You can decide to use a 4-volt battery or a 5-volt battery, but I'll prefer using the 9-volt battery. But then before I do that, I need you to take note of this. This particular aspect of my breadboard is the VCC area, and this particular aspect of my breadboard is the ground area. So that means before connecting my 9-volt battery to the breadboard, I need to make sure that the positive goes to the VCC while the negative goes to the ground area of my breadboard. So connecting that will be this way. Make sure that the red wire is being connected to the VCC and the black wire is being connected to ground, because the red is positive and the black is negative. Now if you look very closely, now you see that there is a black dot over here, this area. Now that black dot signifies the beginning of the pin. So you have here pin 1, pin 2, pin 3, pin 4, pin 5, pin 6 and pin 7. And going over, you have pin 8, pin 9, pin 10, pin 11, pin 12, pin 13 and last one, which is pin 14. Now what I do next is to connect my pin 7 to the ground area, just as I did for my battery, and connect my pin 14 to the VCC. Okay, looking at it very well, it is well connected using my jumper wires. Next will be to connect our inputs. But before then, do take note of this diagram on the book. I did a rough sketch here. I'm really not an artist, but please just pardon me. Okay, this is just an architect of our IC. Inside of this IC, you will find 4 AND gates. You can see the pins, pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. And you'll find out that we've connected our pin 14 to VCC written here, and our pin 7 to ground, as you can see here. But the rest pin, you're having 4 AND gates. So you can decide to choose just one AND gate, or this AND gate, or this one. You have a first input. For the pin 2, you have the second input, and pin 3 will be acting as our output. Same goes for the second AND gate here. Pin 4 will be connecting the first input, pin 5 as the second input, and pin 6 will be the output. And same goes for the rest. Whichever AND gate you want to use makes use of 3 pins. 2 pins will be for the input, and the last pin will be for the output. But in this tutorial, I like going with the abstract, so I'll be using this AND gate. That means my input will be pin 4, my second input will be pin 5, and my output will be pin 6. Now as you can see, both inputs are being connected. Next we are left with our output, which is pin 6. Our pin 6 will be connected to an LED bulb. So I really don't want to make my work tacky here by just connecting my LED in this whole place. No, it will look very tacky. What I do is to create a connection from the output out to this other area using my jumper wire, just like this. It's like taking out my outputs, transferring it to this area. I don't want my work to be very clustered. That is why, to make it very neat, because what I'm using are jumper wires and they can sometimes be very clingy. Next I connect my LED. I make sure that the longer part of my LED bulb is being connected to the output, while the shorter part is being connected to ground. But before then, there should be a light that will pop up. So if your light does not pop up, please once again check your connection of your 9-volt battery. Make sure that the red wire is being connected to the VCC and the black wire is being connected to ground, because the red is positive and the black is negative. So I place in my LED bulb this way. The longer goes in here, and the shorter goes in, and now the light pops up. Oh, we are not done yet. I'll be using this truth table to make some explanation. Please take a look. If I should have my first input as 0 and my second input as 0 also, my output will come out as 0, which is off. So let us see if our LED bulb will turn off as written on our truth table. So just like this is connected to ground level, and also you can see that the bulb has already turned off even before we connect the second input. Let us just connect it for us to understand what we're talking about. So when both inputs are 0, our output also will be 0. Okay, on our truth table, when our first input is 0 and our second input is 1, our output should be 0. So that means our LED bulb will still turn off. And it goes the same for the rest bits. Please, I'm not explaining specifically on AND gates. I'm only using it to enlighten you on logic gates and how they operate. These components are responsible for the arithmetic and logic operations that goes on in the computer. Just see it as a door, whereby if you close the door, nothing goes through it. If you open the door, then something can go through it and come out of it. That is how the logic gates operate. They have just two jobs. And when the gate is locked, it produces a result as 1 bit. But when it's opened, it produces a result as 0 bits. That is how the computer reasons. It's either a 1 or a 0, just like transistors. Although they have different functions, they have various abilities, but they still need to work together to produce a result. That means a single logic gate cannot produce a result, cannot do any arithmetic operation or a logical operation on its own. They need to combine to form what we call a full adder or a half adder in order to get that result. For example, if you do an arithmetic on the computer, let's say 2 plus 2, to get the actual result, 3 main logic gates are being put to use. You don't know what's actually going on inside the computer processor, but 3 logic gates are being put together to produce that result that you're looking for, which include the AND gates, the exclusive OR gate, and the OR gate itself. Now, the amazing part is that these operations or calculations are done in seconds. Well, in respect to your computer processor speed. Let's say if your computer processor speed is 2.5 gigahertz, it means it can execute 2.5 billion calculations per second. So you see it is very, very fast. Please, we'll call it a day, and I hope I've been able to pass a little knowledge to you